my students, uh, welcome to my class. We now discuss today in the theory of relativity and its application. Theory of relativity and its applications. Now today our discussion about the relative character of time. Relative character of time. It is also called the concept of simultaneity. The concept of simultaneity. Before the mathematical expression, our discussion, our expression that here relativity theory time intervals are not the same for two observers in relative motion. Here, two events which appear to take place simultaneously to one observer are in general not simultaneous to another observer in relative motion. Let us consider two sounds of sources are x1 and x2. We now write it for explanation that let us consider two sounds of sources at x1 and another source x2. There they are the different places are the different places at same time. Let us consider this time equals same time t0 to an observer, the situation is different to another observer, like a pilot of a spaceship, or etc., moving with a velocity v relative to the ground. Then the situation is that that the different of any other observer, like that is a pilot of a spaceship, moving with a velocity moving with a velocity v. The observer audible the sound at x1. The observer audible the sound at x1 t1 prime equals t0 minus x1 v by c square by root over 1 minus v square by c square. This is the audible sound at first source, that is x1 source, and this is the time of the interval of this sound, that is t1 prime. This is the first case. So this is equation number 1. And from the second source, anotherly audible the sound at x2. It is the time interval, that is t2 prime equals t0 minus x2 v by c square root over 1 minus v square by c square. Here the source relative distance is x2 and initial time duration of initial time, that is t0, and the velocity of light equals c. This is the equation number 2. From the equation 1 and 2, we can get the event of two sounds occur simultaneously. Then the event of two sounds occurred simultaneously to one observer. separated to another observer by a time interval this time interval, that is delta t prime equals t2 prime minus t1 prime equals x2 minus x1 t2 prime minus x1 minus x2 v by c square root over 1 minus v square by c square. Therefore, we conclude that there is no such thing as absolute time which is same for all observers. This is the simultaneity theory.